Hello everyone and welcome to Azam Shah Weekly. Now this is going to be a fun video because we are going to go over several different architectures, several different common architectures that are available in SwiftUI. All right. And the main reason for creating this video is just to give you an idea of different architectures, and you can choose whichever architecture fits your need. Okay, so let's go ahead and get started. We'll start with the most common architecture which is used in SwiftUI applications, which is called Mvvm, Model View Model. And the application that we're building will be extremely simple. We will simply display some data from an API. So I have already written the web service. You can see I've hard-coded everything. So this is not how you will write your call to get all tasks, or in this case, it's get all products. So let's go ahead and change that. This is just so that we have something that we can go and get the data. So once again, this is not how you will implement it, but I'm just trying to make everything simple without any error handling, anything like that. We have a product struct, product model. Again, making it simple. The product can contain other attributes, other properties, but I'm only getting the ID and the actual title. We don't even need an ID, but we're just getting all of that stuff. So let's go back over here to our content view. And what we want to do is we want to make sure that we're using Mvvm pattern to start with, then we will move on to different patterns. So how do we do it? Well, and I'm just going to copy this into the same file, and then I will make a backup of this file. So I'll start with probably creating a view model. And I would call it, let's say, product list view model, observable object. Okay. So product list view model, which is going to be an observable object. And another thing that I'm going to do is product list view model will be responsible for this whole screen. So everything that goes on the screen, the product list view model will be responsible for that. But individual products that will be displayed kind of like in a row, we need to create a separate view model to provide the data for that. So I'm going to go ahead and create product view model, a simple struct. And in this struct, you can pass in the product, which is the actual model, which is right here. And based on that, we can expose different properties. So I can go ahead and say ID, I guess if you want to get an ID, integer, and I guess it will return you product.id. Okay. We can also conform our product view model to identifiable, so it will be easy to use in our view. And the main property that we actually need is the title. So product.title. Simple. Let's go back to our product list view model. Now we can go ahead and create a publish property. I will call it products. And it will be a product view model, empty array. So product list view model is controlling the whole screen. The products, which is an array of product view model, will be controlling these individual products that you're displaying, an array of products. Now we need to add a function to our product list view model so we can fetch all the data. So I'm just going to go ahead and say populate products. Okay. And we can say that this might be like an async throws function or something. So we can do that. Over here, we can take help from web service. So web service dot, and you can already see that we have a function called get all products, which will be same for no matter what we're using, what kind of architecture we are using. So it is going to return us something. So we could say try await. It's going to return us products. You can name it a little bit different if you want, if you're getting confused with the products and products. Now we can't really assign these products because these products, if you look at what they are an array of product. And this property right there is actually array of product view model. So somehow we need to convert these array of products to the array of product view model. So self.products, this is the array of product view model. This is the array of products dot map, and we can call product view model dot init, which basically simply means that every time you are going to run this mapping loop, you are going to initialize a new product view model, which is this one, and going to return product view model, which will be which will be assigned to products. Okay. Now, I want everything to be in the main actor, so I'm just going to go ahead and assign main. There we go. Okay. All right. So that's pretty much it actually for creating our view model and creating our product view model. Now, the next thing we need to do is we need to use product list view model. Again, there's so many different ways of using it, but I'm just going to just show you one way of using it. So let's go back to our content view, which is right there. Now, sometimes people want to inject this. That's fine if you want to do it. I'm just keeping it very simple. So state object, private var, and what should we call it? We should call it product list view model, and we will create an instance of product list view model. Now you might be wondering, okay, product list view model, how will it get access to the web service? Are we going to inject it over here? Are we going to inject it somewhere else, like probably over here in the app file where we will inject? So all of these questions, yeah, sure, you can do that if you want to. If you are dealing with unmanaged dependencies and you want to mock out some stuff and you want to add a dependency to the product list view model, like for unmanaged dependency, which this is an unmanaged dependency. So if you want to do all of those things, you can mock those things. But I'm just trying to keep it very simple. All right. So right now, obviously, the web service is the only concrete implementation. If you want to add more implementation for it, you will need to add a protocol and a mock service and all that stuff. But just keeping it simple. Okay. So we get an instance of product list view model, and I can go ahead and create an array, which is product.products. So make sure that we have access to the product. So we will not make it private. There we go. And we will get the product in, and now we can display the title of the product by simply saying product.title. And make sure that you call this. So over here we can say something like do try product list view model dot populate products, and try await because this is an async function. We will catch it if there's any error and probably display the error on the screen. Okay, so that should be probably hopefully it. And it will display all the products, as you can see. Okay. Now, if you do have some sort of a validation that you want to do, maybe you have a text box and you want to validate it. So in this particular architecture, the product list view model will be validating everything that goes on for the product list screen, which is the content view in our case. So if I add a text box over here for some reason, and I can write something or I can leave it blank, so that kind of a validation will be done by the product list view model. All right, so this is a very simple, you can see our simple scenario in which we use the Mvvm pattern to create this application. Now, for cases like if you have a plus button over here and you want to add a new product, so you will start by, for new product, and now we're not going to go that far, but I'm just telling you that if you want to add a new product, you will need to add product view model. So every time you add kind of like a new screen, depending on the screen, I guess, depending on the screen, you will add a new view model in those cases. And obviously you will have an add product view, which it will be the view displayed as a sheet or a different, modal. So make sure that you understand that also. Okay. So that is the very simple case for Mvvm when you're using the this architecture for Mvvm architecture for SwiftUI applications. Now let's go ahead and move on to a different architecture. All right, so our next architecture that I'll be talking about is called the MV architecture, which is a model view architecture. All right, so let's take a look how model view is a little bit different from MVVM. It's not much different, but I guess as you create larger and bigger apps, then the difference is kind of like quite clear. Okay. So we're starting with the content view, and you can see it's simply displaying hello world. We have the web service, we have the product, our entity or our actual model is there. So how do we start with MV architecture? So MV architecture stands for model view. So what has happened is that the view model has been kicked out, and then there's model, and then there is view, and that's it. Now, when we talk about model, we're not really talking about these models over here, all right? We're talking about a model that can be the single source of truth. We're talking about multiple models if your app is complicated. Now, again, I am talking about the client-server application. If you're using MV architecture for a different kind of app, which is not a client-server application, then it might be a little bit different, all right? So let's start. So I'm going to create something, class, and now I can go ahead and create a model. So I will call it store model. But you can call it anything you want. It will also be an observable object. So you can see already similarities over here with MVVM. Okay, so now we have a store model, and store model will consist of array of products. So published, var, products, and products. So you can see very, very similar. Okay. Okay, what else the store model will do? Well, the store model can populate the products. Okay, so we have the same exact thing, populate products, very similar. Web service, again, the same exact thing, get all products. So this will be async and throws and all that stuff, async throws. Try, await, we will get the products, and we will simply assign the products, in this case, to products. And we will mark this with main actor. Okay. Okay, so here we go. Pretty simple. You can see that we're not really using any conversion or anything like that. We get the products, we assign it to the products, and we're done. Okay, so how do we use it? Now, this is where we have more options, just like anything else. We can use the state object, which you have already seen. We can use, we can get the data and maybe put it somewhere else, like in a state variable. I guess in this case, we can't really do that because we have to use the store model. But you can use the store model with the state object, as we have done before with MVVM. But I want to show you a different approach also. You can put the store model itself in the environment object. Now, another thing to keep in mind with the store model, or which I like to call the aggregate model, is if I have to get the reviews of the products, or if I have to get some other things related to my app, I'm not going to create a different model, like different store model or different something else. I can just go ahead and write another thing over here. Let's say over here, published reviews for the products for review. There we go. If I am doing something called something else, I don't know, I mean, ratings, reviews, something related to the products, categories, right? Categories. So in other words, this will become kind of like your single source of truth. This will become your entry point to get all the data, to manipulate the data. If I want to perform a search function, meaning searching the products, I can write a function over here also. Now, as your application grows, obviously you can't really put everything inside the store model. Then you have to start thinking about the bounded context. Then you have to start thinking about, oh, well, products and categories are part of the catalog, so I should create this as a catalog. Okay, there we go, done. And maybe I am doing something with the inventory, so I should create an inventory. And this inventory aggregate model will consist of all the different things related to the inventory. So it will manage all the different models related to the inventory. Now, that can be many different things: inventory item, deleting inventory, adding inventory, and so on. Okay. So the difference between this architecture, which is the MV and MVVM, the main difference is basically whenever you create a new screen, like add view model and things like that, you don't have to create a new store model. If I want to add a product, I can just go over here and I can say add a product, and I'm done. Okay. I can pass in the product. There we go, pass in the product. And I guess it can be async throws and all that stuff. And call web service to add product. All right. Once again, I do like to repeat this, that it does not mean that you're going to be doing everything inside the store model. If your store model is getting crowded with like 50 or 100 functions, then you'll have to sit back and say, okay, hold on a second. This is getting out of control. I need to divide it into multiple models based on their domain, based on their bounded context. Anyway, so very simple. Now let's go ahead and see how we can use it. And as I mentioned, you can use it with a state object, not a big deal. Usually what I do in this case is, since this is the only aggregate model I have, there is a possibility I might be using this, or I might have to use it throughout the application. Maybe there is some part of the application who's like, hey, I want to get the products too. So for me, it's much easier to just inject it as an environment object. Once again, this is not the only way to use it. You can still use the state object. That is perfectly fine. I can even write it over here, state object. You can use it, store model, and then you create the instance of the store model. This is perfectly fine. You can do that. I'm just going to go ahead and use it with the environment object. So environment object, private var, and we'll call it store model. And obviously it is going to be the store model. So it will automatically be injected. Now, what about the list? Well, the list will remain the same. So store model dot products. And it is testable. I mean, you can test this out, right? So it's not like the logic is leaking into your view or anything. Okay, so product in, and what do we have to do? We have to do product dot title. And now we have to do the task modifier. So everything kind of like, you can see similar, but not exactly the same. So store model dot populate objects. There we go. Try, wait, catch, print the error. Let's go ahead and see if it populates everything or not. Conform to identifiable. I believe it did conform to identifiable. Did it not? Oh, it didn't. Okay, so in this case, this will become conforming to identifiable. All right. Let's go ahead and run this. There we go. All right. Nice and easy. So this is the MV architecture, the model view architecture, which is basically saying that your view will talk to the model, your model will talk to the view. We have removed the view model in the middle part. And usually most of the cases you use environment object. It depends. Again, it depends if you want to use environment object or not. I usually try to use environment object because now if I am deep down in a view hierarchy and some other view is saying that, hey, I need to get a list of products or I need to get this and that, then this can definitely help. But it's not a mandatory thing. You can still use the store, the state object, which is owned by the view itself. So that is perfectly fine too. Okay. So this is the MV architecture. Now let's go ahead and move to a different architecture. Our next architecture I'm going to be talking about is known as the container presenter architecture, also known as a container pattern. And this is a very common pattern that is used in React applications. All right. So the idea is basically that you're not going to create an aggregate model, you're not going to create a view model, and your view itself will be responsible for getting the data and just passing it to the child view. So one view will be your container view and one view will be your presenter view. The container view will be responsible for getting the data, sorting, filtering, all those things. And the presenter view will be reusable because it will simply be used to display the data. So let's go ahead and take a look at this. How can we do that over here? Let's go and do that. So I'm going to go ahead and use the content view as my container view. So this is the container, the content view itself, which is this one, is the container view. So this means that I will eventually have to create some sort of a presenter view, which will be responsible for, putting or giving the data to the presenter view. Again, you can use environment object if you want to, but since this is a very small application, I'm just going to go ahead and use this. Now, one of the things is, well, we can't really create a state object in this case, right? Because we don't really have a view model. We don't have anyone who is conforming to observable objects. So that technique is probably not going to work. All right. So let's remove that. Okay. So now the question actually becomes, well, how are we going to pass the data to the view? Now, there are multiple options. I can go ahead and say state over here, and I can say products. So this is a local state for the content view, which is a container view. And what we will do is we will go ahead and populate this state. So task do, we're going to try to access the web service and get all products. Now, one of the things you will see is that the web service itself is going to return you an array of products, which is great. That's exactly what we want. Once the products are actually retrieved to you, then we can assign it to the products. Okay, and if there is any catch, well, in that case, we can simply go ahead and do this. Okay, pretty simple. We are going to call get all products. We are going to get the products, assign it to the local state, and we're not going to be using text view, obviously. So now, let me actually go ahead and write it over here that this is the container view. The content view is the container view. So now we have to create a presenter view, the person who will present the data. Presenter view. Okay, so that will be another view, and we will call it product list view. Okay, nice, simple name. We're going to go over here, create the body. Now the presenter view, in this case, which is the product list view, will only be responsible for displaying the data. All right, so somebody from the higher up is going to pass in the data to the product list view, and the product list view is like, well, okay, I'll just display it. Okay, so let's go ahead and say products. So somebody is going to pass in the products to the product list view, and once they pass, we can probably go ahead and loop through it just like before. And product in text product.title. Okay, so that's it. The product list view is kind of dumb. Well, it's a presenter view. It's not really doing any logic, anything like that. It is simply saying that, yeah, if you give me a products, I will simply display the products. So now what we want to do is to call the product list view. So product list view, passing in the products, which is products. Okay. Let's go ahead and refresh it, and there we go. The output is obviously exactly the same, but you can see in this case, we didn't have to create an aggregate root model for the MV pattern. We didn't have to create the view models for Mvvm. So the downside of this approach might be, it might be a little bit harder to test your application. Now, right now, if you want to test your application, you will have to write end-to-end tests. But think about if you were building something with hotels.com, where you have many different filters on the side, like over here, maybe you have a lot of filters, and you want to test that particular logic. If I say Wi-Fi, parking, breakfast, it needs to filter out. The filters need to work correctly. If I'm using this approach, which is the container presenter view, I can still test it, but I will have to probably write an end-to-end or UI test. Okay. So that is kind of like a little bit of a downside of this, because in React and in Flutter, you can actually do widget testing and component testing. Unfortunately, that is not really baked into the SwiftUI framework, so you can't really do those kind of things. All right. Maybe they will introduce it in the future, but right now you can't. You just can't do that. So this is the container presenter pattern, also known as a container pattern, very common when you are building a React application, and it is inspired from React application. One thing to keep in mind, and this is a very important thing, is that when you are using the container pattern, don't try to create a container for every single view that you will add. Don't do that. All right? There will be some views that will be presenter views. There will be some views that will be container views. It all depends on the application. But just to create a container view because you have a presenter view is not a good idea. So don't do that. And that is actually, that can lead to a lot of code, unnecessary code. Okay. So container presenter view, simple architecture, you can see not really much going on. The container is going to be responsible for fetching the data and passing it to the presenter view. And the presenter is like, okay, I'll present the data. Okay. So this is the another architecture in SwiftUI. Now let's go ahead and take a look at the Redux pattern. Now we're going to be looking at the Redux pattern as a plain vanilla Redux. This means that we will have to implement a lot of stuff to get it to work, and I'm not going to implement all the stuff live, so I've already coded it out, and we're going to just take a look at what it actually means, all right, because this is a lot of code, all right. But first, let's go ahead and understand the Redux pattern. Very, very common when you're building React applications. Redux is a separate library in React, but you can use the pattern also in SwiftUI if you want to. The whole idea behind Redux is you have single source of truth, and it's divided into dispatching actions, middlewares for fetching the data from an API, and also updating the global state, which is through the reducer. So let's take a look at this example. This is our UI, so this is kind of like your SwiftUI screen. If your SwiftUI screen needs to update something, all right, meaning update the global state, it will need to dispatch an action. That action is going to go to the reducer and update the state. But in our case, it's a little bit different, and the reason is that we need to fetch the data from an API, and then we need to put that data in a global state. So in our case, it's a little bit different. We'll still use a UI. We will dispatch an action. It will go to the middleware where it's going to fetch the data, get it back, dispatch, which is going to go to the reducer, and which is going to update the state. So one thing to note about the Redux pattern is that only one person is responsible for updating the state, which in this case is the reducer. Now, you can have multiple reducers in your application, but in the end, they all kind of like join together to form one reducer. All right. Now let's go ahead and take a look at it. I know if you have not been doing, or if you have never done Redux, and if you have never done React, then it may look very complicated, and it kind of is. I mean, if you want to implement the whole thing again, it will be very complicated. In React, we have libraries like Redux that can do all of this stuff. Still, in React, it is complicated even with the library, all right? So let's go ahead and take a look at all the different things that you have to do to implement a plain vanilla Redux. Now, there might be some Redux libraries in SwiftUI that you can use, that's perfectly fine, but plain vanilla Redux. So looking at the diagram, we obviously need some sort of a state. This is kind of like our global state, all right? So you can see that I have a lot of code over here, like a lot of code. And over here, you can see the Redux state. And this is our app state. App state basically means that we will be storing this in our global state, okay? And what is a product state? Well, it's just a list of products. That's it. So this will be our global state. Who is the person who manages the state? Well, that will be your good old store. The store will be managing the state. So a store is going to receive events from the reducer. Inside the store, you will have reducers, and reducer will be responsible for updating the state. So reducer is the only one who can update the global state. So now let's go ahead and take a look at some reducers. You can see we have middleware, we have app reducer. So this is kind of like our root reducer. Remember I mentioned that even if you have multiple reducers, there's only one root reducer. So that is our root reducer, which is the app reducer. And this is our particular reducer, which is only interested in updating and managing updating the state of the products. So this is the products reducer. Okay, so all of these things, now we have to look into dispatching, because so we have done this part, we have this, we have this, we have this. We need to check out the middleware first. So let's go ahead and check out the middleware. So middleware will be used to basically fetch the data from the API. So let me see if I can find the code for the middleware, which is right here. You can see the middleware is actually fetching the data. It's still using the same web service that we use, which is the web service for get all products. You can see this, I'm not really using action. I use this code from somewhere else, from my older project. So I'm not really doing action, I'm just getting all the products in this case. Okay. Dispatching events. So these are the events that are going to be dispatched from your client, meaning your SwiftUI application. As you can see over here, your UI, SwiftUI, is going to dispatch an event. So these are all the events that are available. You have an event called fetch products, set products, and so on. How do we dispatch these events? Well, in our content view, which is the same view we're using, we will get access to the environment object, which will have the store in there. We will expose some local props, which will have the global state for the products and which will have events. These are the dispatches on fetch products. So now we're going to go ahead and simply call on fetch products anywhere we want, which is right here. And what this is going to do is it's going to update our global state, and then it will simply give us the global state in local props, and then we can use it. It all sounds very complicated. Trust me, it actually is, because we're implementing the whole thing again. You can see there's a lot of code just to get the Redux thing working. Now, having said that, all of this code you have to type. Well, you have to set up the framework once, but once it is set up, then you can use that. All right, so this is a Redux, a plain vanilla Redux implemented for SwiftUI application. That is another architectural pattern which is very, very famous in React applications. All right, so this is plain vanilla Redux in SwiftUI. Another common architecture that people are using for SwiftUI application is the composable architecture. Now, I can't really show you any code for that I have written because I haven't used it yet, but it's also a very popular architecture. If you look at the code, it's quite similar to Redux. You can see the actions over here. You can see the reducer. So there are some hints of Redux in this architecture. You can see the actions, all of those things, middlewares and all that stuff is going on. You can definitely use it. It's very popular. Since I have not really used it, I don't know how it actually works and how is it different from Redux and how is it different from, Flux and all that stuff. But definitely try this out, and I will try to link it to some videos for the composable architecture so you will have a better understanding. So I'm not basically qualified enough to show you some code for the composable architecture since I have not worked on it. But keep in mind that this is also very popular architecture, and a large number of apps are written using the composable architecture. So definitely check it out, try it out. The best way is to try out all these architectures. Now, there is no one fit architecture or one architecture that is going to be for your application. I mean, you can use Mvvm, you can use Mv, you can use container pattern and all that stuff. You can use, as we learn about the Redux, but you can see the Redux, a lot of boilerplate code you have to write to get the Redux to work if you're implementing from scratch. So all of these architectures are available to you, and try to see which architecture is fit for your needs. Don't go with like, oh, I'm going to use this and this is it. No, I mean, sometimes you're building application that will require a particular kind of architecture and it will fit with the particular architecture. So that is a much bigger discussion because that is based on the project that you're working on. Okay, so hopefully you have enjoyed this video. You can download the source code also. I will put it on GitHub. You can download the source code, play along with it. You can see that I have separated out all of these different things that we were learning into separate files. They're all commented out, so you can uncomment it and then try to use it in a content view if you want to. That's perfectly fine. And that's pretty much it. Hope you have enjoyed the video. Thank you so much. And hey, you know what? Check out the courses. Check out the links for my courses in the YouTube description. I have a lot of courses I have courses on Mvvm. I have courses on MV architecture. I have courses on Redux architecture. So I have all of those courses. So I'll link that right there in the YouTube description also. Hope you have enjoyed it. Thank you so much.